it is lecture number 19. Again, I am talking about joint PMF. So once I will start with one very simple kind of joint random variable. Here in joint random variable, I won't discuss about how to find joint PMF directly because it is very easy to find distribution of joint random variable with respect to other simple random variable that just you can relate it with linear algebra concept that you might be aware of that you are if you are taking any point from R2 that always that point happens to be a linear combination of any two a special kind of element. Those a special element we are calling it basis element. So similar kind of things we observe. So joint sometimes it happens that joint random variable can be expressed as a sum of some special kind of basis random variable. So that criteria for that perspective, I had already taken one example in last lecture that I had told that binomial random variable easily you can generate from Bernoulli random variable, and Bernoulli random variable it is associated with a single trial while binomial random variable is associated with n number of trial. When there is n number of trial, then we are introducing binomial random variable, and with respect to each individual trial of that binomial random variable we are associating Bernoulli random variable. From that segment we can say that binomial random variable happens to be as a sum of independent Bernoulli random variable. And whatever, if you want to discuss anything about binomial, just go and discuss about Bernoulli. And Bernoulli random variable happens to be very simple. It is just binary kind of random variable. It is taking only two values, either 0 or 1. So that's why very easy to deal with. We can easily find expectation. We can easily find variance of Bernoulli random variable, and from there easily you can derive binomial random variable. Later we will see that when number of trial happens to be very large, it is tending to infinity. Then that in continuum perspective, binomial will be converted into normal. So you can say that binomial random variable happens to be a discrete counterpart of a normal random variable. So here I have taken a question. Suppose that n people throw their hats in the box. There is a big box in which and in that neighbor near about that box there are n people. They are throwing putting that hats in box, and then each picks up one hat at random. Then here question is that what is the expected value of x, the number of people that get back their own hat. Their that means they have to take their only their own hat, not others hat. So what is the expectation of that? So we have to find expected value. So what in order to do that, first we need to introduce Bernoulli random variable. So for ith person, we introduce a Bernoulli random variable xi. It says that either that ith person will take value, that xi will take value if ith person is getting his or her own head. If it is that person is ith person is not getting his or her own head, then xi will take 0. So easily we can introduce Bernoulli random variable with respect to each person. We can introduce Bernoulli random variable. Each person, either that person will get his own head, or that person may not get. In that case, it will be xi will take 0. So this xi that introduction of xi is very simple. Okay. Now coming to find expectation and distribution of what is the probability mass function of xi, it is very simple. When xi is taking value 1, then probability is 1 by n, because there are n number of people and all are equally likely kind of a event there. So that's where we always define equally likely. So probability always happens to be 1 by n. Just take reciprocal of n. And when xi is taking 0 value, then probability is 1 minus 1 by n. So you can say that this one is probability of success. That means the probability of getting uh, on head. So that's why this is probability of success, and we have already seen that we can easily calculate expectation of a Bernoulli random variable. What that one is directly equal to probability of success, and that happens to be 1 by n. So easily calculation is very simple. Now our question is here that you have to find expected value, that number of people that get back their own head. So here x is not a Bernoulli random variable. Actually, it is a binomial random variable. It is talking about number of success in n trial. Number. Remember that when someone is there is a random variable and it is talking about number of success in n trial, then that kind of random variable always happens to be a binomial random variable. And if you go through basis approach, then you can easily see that binomial random variable happens to be summation of n number of Bernoulli random variable. And Bernoulli random variable x1 is associated with first trial, that means first person, x2 is associated with second person, and likewise xn is associated with nth person. So that's why we can say that binomial random variable, this x is summation of this n number of Bernoulli random variable. And if you talk about success of x, then it is talking about you may get first person may get had his own head, or second person may get uh, or suppose you can say that a number of person may get on head. So that would be the scenario. In such a way you are saying that you are getting a success out of n trial, case success out of n trial. So that's where the x is a Bernoulli random variable, binomial random variable. Now coming to talk about independency between first trial and second trial. Say it is very much associated with independent event when you are tossing a coin several times. So I had already mentioned that we had also seen that getting head in first toss, definitely it would be independent with respect to getting head in second toss. So all each one activity which is associated with one trial definitely would be independent with respect to other uh, activities with respect to which is happening in other trial. So that's where x1 is independent of x2, x2 is independent of x3, and likewise xn is independent of x1. So pairwise independent, you will observe that. I will discuss in detail regarding independent variable as well. So I have already discussed about the independent event. Now, then after I will discuss about independent variable, random variable as well. So in overall, I would like to say that x is a binomial random variable which can be represented as a sum of n number of independent Bernoulli random variable. So it is very easy to calculate expectation of x. It would be just, if there is a independency, then easily it would be just summation of this n number of expectation of n number of Bernoulli random variable. And how, what is the expectation of each Bernoulli random variable? It is 1 by n. So just multiply n with 1 by n, that means 1. You are getting expectation of binomial random expected value of x is 1. So what does it say? It say that in average one person definitely will get 1 hit. That is the meaning of expectation. So it was just a function of binomial random variable as a multivariate function of Bernoulli random variable that I had expressed as a multivariate function of Bernoulli random variable. So that you had already seen that. Okay. So further, if you try to understand joint random variable, so here I have taken few example, few different example. So from there you can observe those random variables. So both kind of random variable I have taken, discrete and continuous. So first I will discuss about discrete. Like if you are taking two numbers, so or simply take a dart, and what you do, just keep on hitting, keep on hitting and collect the coordinate of point. So if there is a dart, then definitely randomness will come there if you keep on hitting. So you can't say that you will hit at the exact point uh, every time. It is not possible. Always you will hit somewhere else. So what you do, you collect coordinate of those points. So it is a your dart is a plane kind of thing. So every point will have two coordinates. So one coordinate you collect like along x-axis, another coordinate you collect like y-axis. So you can observe this joint occurrence of points. So joint occurrence of points, it is giving a joint random variable. And when you are hitting, it is not a continuum. Definitely you can't get a continuum point. Definitely you will be tied. So in practical situation, you observe discrete number of discrete. You observe that hitted point in discrete fashion. It is not in continuous fashion, but dart happens to be continuous, having continuous sample space. But when I would like to talk about from their perspective, then what will happen? It will be discrete in fashion. In practically, it is discrete in fashion. Similarly, this one is also example of like someone is saying that this one was dart was like of a square shape. So then you are observing this kind of scenario. If someone is saying dart is like disc shape, then what scenario you will observe? you will observe this scenario. So this one is another when we will study continuous random variable normal. It is giving normal distribution of normal random variable. So that kind of pattern is coming. So all these are from practical situation. This happens to be discrete in situation in in the in nature this happens to be discrete, but always we talk about when number of tends to infinity, it will approach to continuous situation. So that is the scenario. Another scenario, it is coming like this one, this scenario. So all these are intensely I have taken this example. I will take this example again because I have to, when I'm talking about joint random variable, I have to discuss about dependency and independency between those random variable. So that's why I have taken this example. So clearly, if I'm asking what is the relation between this one, whether these random variable x and y are dependent or not, who would like to say comment over whether there is any dependency between these? Anyone after seeing the graph, can you comment over this? Abhishek, you need to respond. I never find you attentive while in class. Aditi, would you like to answer dependency between random variable x and y? If you are able to listen me, then respond it. Are you able to listen me? Okay, would you like to comment over this in second picture that do you see any dependency between random variable x and random variable y? Is there any dependency? Okay, no worry. If you don't know, then definitely you will know after further. I will discuss about. Right now, intensely, I am asking this question. If you are having a, just try to observe from uh, pictorial perspective. So what you see, if you come to this plot, so you see dependency. You can say that y is a linear function of x. Y is a linear function of x. So easily you can see that y and x are highly correlated. But here correlation is the measure of dependency here. When you correlation and covariance is the measure of dependency when you are dealing with discrete points or discrete random variable or any kind of random variable. So covariance and correlation. So those things I will discuss here. So here also you can see that here you don't observe any correlation between value of random variable x and value of random variable y. Similarly, you observe very less correlation between random variable x and y. And here you observe very high correlation between random value of random variable x and y. So this is actually joint random variable. Jointly these are agree. Another piece of joint random variable I will talk it here. Like suppose we are having one random variable x, and that x is taking continuously value between the interval x1 and x2. That means x is taking value from here to here. Okay, and y is another random variable which is taking value less than equal to y. So in that perspective, what is the joint area? This is the joint region of the value of random variable where x and y both are jointly taking value. So this is the region. So if you talk about this region, we don't have any information. Just we are having information about this region in which x and y both are taking value jointly. So this region is talking about joint reference of x and y. So that's why x here variable x and y are joint random variable. Similarly, if you come to this example, if suppose the first random variable x, it is taking value between x1 and x2, and second random variable is taking value between y and y2, and simply we will say that the joint random variable x comma y, here joint random variable would be x comma y. We denote random variable always by capital letter. Always you remember that. And the specific value of any random variable we denote it by a small letter. Specific value or particular value. So with that we denote it by a small letter. So if you take any value from this rectangle, then that would be one specific value of this random variable. So here x and y jointly varying. So this is the region where x and y jointly vary. So where we need to study the joint probability distribution of x and y in this region only. Outside this region, we don't have any idea. So definitely probability mass function outside this region would be 0. Another example here I have taken that suppose x1 is here it is greater than mod x, like this way. This scenario, from that perspective, you will observe that, or simply you can say that x1 is absolute value of x1 is absolute value of x1 is greater than uh, x1. Random variable x is taking a value, real value, whose absolute value is greater than mod x1. So what is meaning of that? X is taking value either this side or this side. Okay, and y is taking value between y1 and y2. From there, we observe that this region and this region both are the joint region where the random variable x y vary jointly, and where we can introduce joint probability mass function only in this region. Outside this region, we don't know about the variability of x and y. So that's why the probability mass function outside this region would be 0. We are having information about this region only. So all these are joint variability of two random variable, or joint occurrence of two random variables. So that is all about. So I will take few problem. So here first problem is that you have to find joint probability mass function of a joint discrete random variable. So how we can find? So I have taken one very interesting example from again like communication perspective. Suppose there is a packet switch which has two input ports and two output ports. At a given time slot, a packet arrives at each input port with probability 1 by 2 and is equally likely to be destinated to output port 1 and 2. Okay, these are the given information. Suppose x be the number of packets uh, dist- destined for port output port 1, and y is the number of packet destined for output port 2. Okay, then we have to find the joint probability mass function of x and y, and also we have to find the graphical representation of this one. So okay, time if you, okay, I will graphical representation I will give as a homework for you. You all can try yourself. So I will give a formula of what is the how to find joint PMF of x and y. So just come to introduce few things. See the outcome for an output port J, they will take two value, either it will be 1 or 2. The output for an outcome for an output port J can be following. There are this scenario. Either there would be no packet arrival with probability 1 by 2, either A1 packet arrival destined for port 1 with probability 1 by 4. So here situation is no, no with probability 1 by 2, yes with probability it would be 1 by 2. Yes with probability 1 by 2, but yes is divided by further two branches. Either it will go to port 1 or it will go to port 2. So this scenario is coming. So here if you observe in this node, it is divided into two part. 1 by with probability 1 by 4 you will get no packet arrival. With probability 1 by 2 you will get packet arrival. Okay. Further, it will be divided into two ports because there are two output ports. It is already mentioned there are two output ports. So the yeah, arrived packet, it may either go to port 1 or it may go to port 2. So it will go to port 2 with probability 1 by 4, and it will go to port 2 with probability 1 by 4. Equally likely is already mentioned. Okay. So now everything is already mentioned here. So just we have to underline the sample space that consists of their pair of input outcomes, the mapping of all these output and the corresponding value I have already taken in this table. So here table is coming here. Suppose no output in the both, okay, in the for both case, both random variable, we are getting no output for both random variable. We are getting there are two random variable x and y. For both random variable, no output. One scenario would be no output. It is only one case would be. So that would be no output means 0 0. X is taking 0 value, y is taking value 0 value. So what are the possible value of x? Either either it will x will take 0, or x will take 1, or x will take 2. Similarly, y will take either 0, or y will take 1, or y will take 2. So this is the scenario. So another scenario is coming. That means no no arrival. So this is no arrival of packet. Yeah, one arrival to via or one arrival or one output. You are getting output via what you are port one. So this event, so likewise we can introduce all these events. So this one is talking about x is taking value 1, and that means y is taking value 0, and likewise 0 1 1 0 2 0 1 1 0 1 1 1 and 0 2, all these are coming. So we have to find the probability. So how we can find the probability? So first we have to find the probability distribution. So find the probability distribution for the joint value of 0 0. So it will talk about x is equal to 0 and y equal to 0. What is the probability that x is equal to 0? So we had already seen that here 0, x is taking value 0 with probability 1 by 2. Okay, and when this division is coming, it is further divided into two scenarios. This one is probability of failure, probability of getting no output, and this one is probability of getting uh, uh, output. So it will be divided further into two part, port 1 and port 2. Okay, so that's the probability of getting 0 0. That means x equal to 0 and y equal to 0. It would be 1 by 2 into 1 by 2. Independent for one scenario for x, another scenario for y will also we will have similar plot. Okay, so that's why probability that probability mass function for 0 0 it would be 1 by 4. Now coming to probability mass function for 1 0. What is the 1 0 scenario? Where you observe 1 0 scenario, you observe either this or this scenario. So here you observe uh, uh, two two times 0 1 1 in this case, another in this case. So how we can calculate? So x here it is saying x is taking value 1 and y is taking value 0. So x is taking value 1. That means, so what is the probability of that? Probability that would be 1 by 4, and y is taking value 0. That probability would be 1 by 2. So this is the probability, and it is happening two times. So we are multiplying it with 2, and the resultant probability is probability value of probability joint probability mass function is 1 by 4. And similarly, we can calculate all these value. So from here you can calculate. So this value has been calculated, and if I put, I would like to put all these value in tabular form. So tabular form always like it is very easy to calculate further things from tabular form. So this is the tabular form. You can say that x is varying along a horizontal axis. So value of x we have taken along horizontal axis, and value of y we have taken along vertical axis. So y is taking 3 value 0 1 2, and x is taking 3 value 0 1 2. Now easily you can observe that if x and y both are 0, what is the probability mass function? It is 1 by 4 that we have already calculated. If x is taking 0, x is taking 1 and y is taking 0, that means x coordinate we have to put it for 1 0. So this scenario is coming. So what we have calculated, it is 1 by 4. Calculation is very simple. You can calculate it. If x is taking value 2 and y is taking 0, that means 2 0 2 0. So where we have calculated 2 0, this is the 2 0 event. 20 event, this is the 20 event it is talking about, and that probability 20 means x equal to 2 and y equal to 0. uh, X equal to 2, y equal to 0. From there you can easily calculate, it is 1 by 60. Okay, so all these are coming in together. So these are the value. Further, if someone is asking question that what is the marginal PMF? So I had already mentioned that if you are willing to calculate marginal PMF uh, of y, then you do row sum. So some row that is giving your distribution of y only. That means probability mass function of y. If you do column sum, then that would give marginal PMF of x. So what is the column sum of 1 plus 1 by 16 plus 1 by 4 plus 1 by 4? You sum it up. So it would be 4 plus 4 plus 1, 9 by 16. 9 by 16 easily you can find it. So try to calculate every problem related with the given problem. So try to, so that you won't face any problem. What would be this sum? This column sum, it would be 1 by 8 plus 1 by 4. That means 1 plus 3 by 8. Okay. Similarly, it is 1 by 16. You can uh, observe further what you do. So every marginal PMF always happens to be a PMF, and PMF always satisfy a normalizing condition. So you can verify that sum of these marginal PMF for X would be 0. It would be, sorry, it would be 1. That normalizing condition. So sum it up. It will be 9 plus 6. Sum it up further, you will come to know. Sorry, it will 9. Sum it up, you will get that it is satisfying 6, that normalizing condition. Okay, so you can verify that 9 plus 6 plus 1, that means 16. So sum it up, it is giving 16 by 16. So marginal PM of Px of x, it again a probability mass function. Similarly, you can verify why if you sum it up all these value, if you take summation over all the x value of x, so summation would be 16 by 16. That means 1, normalizing condition. Similarly, if you do summation of all the marginal PMF of y, then what you will observe that summation again, that would be 1. That means it is satisfying normalizing condition. So we can say that if you are having a joint PMF, so here it is very tedious task to calculate joint PMF. Here number of outcome happens to be very small, so that's why we could calculate joint protein mass function. But in general, if number of sample space happens to be very large, even in case of discrete, things are very complicated, and we will choose another criteria. So here again, if you sum it up, it would be 16 by 16. That means equal to 1. Normal. So both marginal PMF happens to be PMF or PMF because they are satisfying normalizing conditions. They are positive, non-negative. They are non-negative, and every property has been satisfied for being a protein mass function. Now I will take one more example. Here, consider a random experiment. It is consist of two rolling of dice. So if you roll a dice, then easily if you roll a single dice, outcome would be 1, 2, 3, 4, 5, 6, 6 output. If you are rolling another dice, that then in that also you will observe 6 output. So that here you are observing 6 out, two dice, and x is we are associating two random variable. X is talking about that outcome you observe in the first dice, and y is the outcome you observe in the second dice. So so because you roll both dice in together, that means you are talking about joint occurrence of x and y. So you have to find probability mass function, joint probability mass function of x and y. So that will give joint occurrence of x and y. So, and also I'm associating one question that you have to find the protein mass function of random variable, these two random variable. So this minimum of xy again. So you are having two random variable x and y. Now you are defining a new random variable z, that you are calling it is actually function of the given random variable x and y. So you can represent it like this way: z is function of x and y. Z is a new random variable. So just here I am asking Z, what are the possible value of Z? Who would like to say what are the possible value of Z? What would be possible value of Z? You know that X is taking 6 value. 1, 2, 3, likewise it will go up to 6. And Y is also taking 6 value. 1, 2. So tell me what are the possible value of Z? I think I should get answer of all these simple questions. Everyone need to be interactive. It is not like that just I'm teaching in a very monotonous way. Everyone, if you want to understand, I need your 100% efficiency and participation in this class. Yes, yes, Sirsagar. What is? I'm listening. Okay. What I will say, it might be network issue. I can't say. Okay. Otherwise, if such issues are there, then I will upload the recorded lecture as well further after this class. I'm recording through PPT as well. No worry. There also you can put your doubt there. So always raise your doubt. So if you are putting your doubt there in Google Classroom, I would like to answer there as well. So keep on asking your question. So don't think that if I could not listen properly through network issue, then it is not like that. Just leave that question. Just try to understand it. Okay, you can put your question there in Google Classroom as well. So that's why those platforms are. I'm using those platforms, YouTube and Google Classroom. All those I'm using. So I need participation from everyone. Okay. So here question is that we have to find that. So I told that here what are the possible value of z. So here z is a function of x, y, and here we are f is defined like this way: minimum of x and y. Minimum of x and y. So it is one kind of function. You can also define another function, max of x and y. You can define various function you can define. So what are the possible value of z? Possible value of z will be also it will vary from 1 to 6. So here one we are finding probability for just one specific value of z, that minimum of x y equal to 3. So how we can find that? So for that perspective, we have to visualize the joint probability mass function and all the outcome also we need to visualize. So the joint probability mass function for z that is j x is taking j value, that j varies from 1 to 6, and k that k is the value one specific value of y, and y is varying from 1 to 6. It is given by the following two dimensional table. You can observe that. So this is the joint PMF. So this along horizontal axis we are taking value of x. So what are the possible value of x? 1 2 3 4 5 6. Along vertical axis we are taking value of y, and what are the possible value? 1 2 3 4 5 6. All these are the value. Now here our event is that minimum x y equal to 3. So where minimum of x y you will observe 3, minimum where you will observe minimum 3. So it is if you walk along this here. So here x equal to 3 and here y equal to 3. So if you take any event along this, if you take any point along this, then that would reflect this function z, and minimum of x y equal to 3. Why? Because we know that what is the name of this point? This point is 3 comma 3. That means x equal to 3 and y equal to 3. Then if both are taking same value, then minimum of 3 and 3 will be 3 itself. If you come to 3 here, then here x is equal to 3 and y equal to 4. Minimum of 3 and 4 is again 3. If you come here, x equal to 3 and y equal to 5. So minimum of 3 and 5 is 3. So here it is coming in this event. If you come to here again 3 comma 6, that means minimum is 3. Likewise, if you can proceed like this way, this one would be what 3 comma 3. This would be 3 comma 4. Sorry, here 4 comma 3. This one would be 5 comma 3. This one would be 6 comma 3. So again, so along this L shape area, you observe the L shape region. You observe that Z is taking value equal to 3. Now here question is coming that what is the probability for minimum x y equal to 3. So you have to find probability of this L shape area. So what you do, just sum it up, then you will get your desired probability. That's you are going to calculate probability that minimum of x y equal to 3. So sum it up the probability of this joint probability along this L shape. So that would give desired probability. It would be equal to 1 by 42 plus 1 by 42 plus 1 by 42 plus 2 by 42 plus 1 by 42 plus 1 by 42. So in total, so 3 plus 2 5 plus 3 8 8 by 42. It will, you have to sum all these probability. Last one I am writing it, it is 1 by 42. So sum it up, what you will get, your desired probability is 8 by 42. So easily in the single problem you can define various problem. In the single given exercise you can define various problems. So another exercise you can do, consider that as a homework. Find the first you find the marginal PMF of x and y. Okay, then you find conditional PMF of x given y followed by conditional PMF of y given x. So you have to find both marginal PMF and conditional PMF. Find the this conditional PMF of x given y, and so all these are homework. So always do that homework. Conditional PMF of y given x. And I had already discussed the derivation of conditional PMF, how it is coming, how it is related with joint PMF and marginal PMF. You can say that. Just again, I would like to, for your simplicity, I would like to write formula for conditional PMF of x given y. That means it is just coming from the definition of conditional probability, I would like to say. So those are elementary probability is very interesting. Say today conditional PMF of x given y, it can be defined as ratio of joint PMF of x and y divided by corresponding marginal PMF of y, because you put condition over x through y, so that's why you have to divide marginal PMF of y through which you are willing to put condition, so that probability mass function would come in the denominator. So that's where this is the definition of conditional probability mass function. So use this definition and find this, and here use the condition of row sum and column sum, find the corresponding marginal PMFs. So that is the homework. You just try to solve it. So it is already about 45 minutes. Other things I will discuss in next class. And regarding attendance, mark your roll number there in the comment box. If you are having any question, you can ask. Otherwise.